Vamos a empezar ya.
Well, we're going to get started. My name is Alejandro Ramos. I don't know whether some of you may know me. I used to have a security blog, and now I work for ING in security, and I collaborate with the European University as well in their master's degree. I've written a book called Hacker Epico, and that's it, really. That's who I am. I've been looking at this whole issue of cookies and privacy for about a year now, working in different, or writing in different fora, working with them, and this is the very latest about the methods used by companies to be able to follow users and also governments. So we're going to look at what kind of mechanisms they have. So if we have a very brief introduction, I would remind you that this workshop is going to be 2 hours long. I'm going to show you these methods, but we're going to see really what's the most basic to start with. What is a cookie? A cookie is a mechanism which is established in the HTTP protocol to store the session, and in fact it was Amazon that decided to create this system because they wanted to have a shopping basket, and even now they've got a patent which seems a bit crazy, but back then Amazon thought it was quite novel back then, the idea of shopping online with a shopping basket, and they painted it. So it's a kind of witness which records certain characteristics so that every time there is a connection with the server, that person or that user is identified and we know who it is. Other things that can be done when we identify a user, we can know which pages they have traveled. We can keep a website authenticated for a user. We can establish different authorizations. We can know what products they've looked for. We can know what they've looked at on the web, even what keys they've hit. And the difference between session and non-session is the fact that in one we can know exactly who's on the other side. For non-technical people, something that is surprising is Open Web Analytics, which is an open source tool. It's a bit like Google Analytics, but this one is one that anybody can download and have on their website. So I'm going to identify myself. Okay, so here we go. This software is the typical one with statistics, where they come from, what they've looked at, what words they've used. So I have it installed in web for a country cottage, just an ordinary website. And here we're going to look at the power of this kind of software. Well, we're going to talk about these kind of messages as well, but here for the moment we'll just accept. We can see that this is a website with publicity adverts for the different cottages or houses that you can hire, different options, news. It's also got a contact page. And in order to understand what this means, we are going to use it by way of example. So your name, Alex, my email. Let's put Ramos F. Hang on a second, where's the at? This is a strange keyboard. Okay, Ramos F arroba hotmail. Subject, a question about beds. Message, I have a question about whether you have waterbeds. I am going with friends. And then I think, oh, that sounds, it sounds a little bit dodgy. So I'm not going to click on send because I'm embarrassed about that, about talking about the waterbeds and girlfriends. Okay, so what could the owner of the site see after that? Well, the next day they could come here and they'd say, I want to see who's been looking at my website and what they've been doing. And you'd see the typical information, the number of people that go to the website, the cottages that are there. And one of the interesting things, and this is what's called downstreams. DOM-streams. And we're going to see that it says play on the right for each of the options. we can see how they used the mouse and how the user kind of browsed around the website, around the page in particular. I'm sorry, let me just put in the right address. So I go back in, I go to DOM streams again, and so if I click on play, if you can see at the top on the right, I have a kind of control panel for video, and if I click on play, this is going to show us how the user has been moving around the screen. If you look, we can see that it's doing an automatic scroll. We ought to be able to see, well, we've got the black cursor. That's not mine, it's the user's, but it's not registered. Let's see this other one. It didn't register the keys, and it should have done. Maybe it's the next video. It's scrolling again. Let's see, it's going a little slowly. And here we have the cursor, that's the user's, it's not mine. You can see it clicks on the red, and it's like we have a kind of spy software on our computer, so we can know what a user has been doing without actually, even though they never actually sent the form. So imagine this in any application that you connect to. Imagine they have that ability. Why do they normally do that? Well, what's the idea behind it? Because they do color maps, the marketing companies do color maps where they try to color in the areas where people use their mouse, or their cursor, to know which is the most important part of the website in order to put an offer there or a promotion in that corner. That's the theory, but in reality what it means is that we're exposed, and without, I mean, even though we don't send the information, they still see it. So even if I type it in and then delete it and then type a different phrase, all of that gets recorded, and they can see, even though we don't send it, even if we delete it, they can see it. This isn't any strange software. This software is just like Google Analytics. It's an open source program and it's for statistical data, but when it comes down to it, the ability to identify a user and the richness of the web world right now allows us to carry out these kind of actions. Well, we were really, how many of you were aware that a keylogger could be installed like that? Half of you, more or less. I'm going to ask lots of questions to get you involved. So cookies have specific characteristics, at least the traditional cookies, which are, well, when it comes down to it, they have an expiry date. So when I go onto a website, the witness or the cookie is going to be spying. It's not going to be constantly authenticated and will in the end expire. So if it's not HTTPS, it's never going to be sent. So if there's someone in the same Wi-Fi as me, they're not going to steal my session. And there's another characteristic, which is the HTTP only, the last one. That means that the cookie cannot be accessed via JavaScript, so if there's a vulnerability, it won't be stolen, and that's a preventive measure to stop them from stealing my identity. So in the end, cookies, well, just like we've always read, they are small text files, and, well, at least in the past, they were stored in the computer. Nowadays, they are stored in other databases depending on the browser. But what makes a cookie unique is that the browser saves something which next day when we open up the browser is going to consult. The standard cookies are the simplest ones, and we're going to have a look at this in order to understand what we're talking about. The standard ones here, they are defined in two RFCs. They're established using an HTTP header, and they have one path or another depending on the browser, which defines where they're going to be stored. And this is the cookie that should be used. Here we have an example of what a browser would do when it is establishing a cookie. It sends a request to a website, and then the server sends the header back with a set cookie, and the set cookies are always a value plus, or they have a kind of an equation. Here we can see name 2 equals value 2, and in the second case we can see the expiry date. If it was safe, it should say comma secure. Other kinds of cookies, legal cookies, which are not really the subject of the talk today, but just like before, we have to be aware of their existence. They are the ones that are done using HTML5. With the arrival of HTML5, browsers realized, the people that are doing the websites, realized they need to store more information than was provided by the previous cookie, because it was a very short text file. So they created web storage, which is unlimited storage, and in a cookie we can store all of the information that we want. And in addition to standard cookies and HTML5 cookies, we can also talk about the ones that can be done using Flash. Fortunately, Flash is dying, as you all know. Nobody is supporting Flash. It's not got much time left, but back in the past they were used quite a lot. And then we have other ones that were used in Internet Explorer up to version 10, which were user data, because Internet Explorer was a bit slower and the programmers found a little trick to store information in Internet Explorer. And we'll see a little bit more about that further on. So these are managed by the browser in an appropriate way. So they are legal and they are backed up by the law on data protection and such like, and cookies. So if I go to delete the cookies, I can delete all of the cookies, and I can control to a certain degree their behavior. But now we're going to look at the other types of cookies. If we talk about HTML5, the most common one is local storage, which is storage in the browser. It's very common, frequently used, that exists. In addition to this, we have 2 mechanisms for storing information in the browser, which would be the API file, which the browser has itself, and something which is based more on databases. And here we can even consult the cookies as if they were a database using IndexedDB or WebSQL in previous versions. And then we have app cache. I don't know whether you know, but when it comes down to it, this is a way of caching. It was something created in HTML5, so it was for caching a whole website in order to be able to allow it to work online. So I could contact Gmail, everything would be downloaded into my cache, and I can work in Gmail without it being online. And then when I connect, then it carries out the actions that I've done. So these are the mechanisms of HTML5 for storing information. If we talk about local storage, they don't use HTTP headers. They do it all using JavaScript. And here we have an example with 3 very simple functions, which I copied. I found them. And here we can see how the storage is done using JavaScript. And here I've got everything on. I've got videos for everything, but we're going to see what cookies this computer has. It's not my computer. I don't know anything about it. It may not have anything, but it could be useful as an example. So if we go to configuration, the advanced options, privacy. Okay, it doesn't have a lot. Here we can see all of the cookies that are stored on this browser in a controlled way. We can see, for example, Google.s is doing different kinds of, or using different kinds of storage. We've got local storage, we've got the database, which are the IndexedDB, and the service workers. Then we've got the channel, which is specific to Google. Here again, technet.microsoft.com. So I'm going to go to TechNet website to have a look at them. TechNet, sorry. So we'll take a quick look at that. I'm going to open up the developers tools. And here in resources, we can see everything that's inside that website. We've got local storage, and session storage is another way of storing cookies. I haven't mentioned that because it doesn't remain, because when it's closed, then everything is deleted. Then we've got the standard cookies and the application cache. And the web SQL and IndexedDB are there as well. So in local storage, we can see a cookie, like a traditional cookie. We've got the key and the value, and the same with the rest. And throughout this talk, we're going to see a bit more about this because it's very useful. And from here, I could delete them, I could modify them, I could see them all. And here we can see all of the attributes. I was trying. Well, just one moment.
Tratando de que se viera abajo en vez de arriba.
I was trying to put it at the top rather than at the bottom. I want to. That's right. That we can see it better that way. We've got resources, cookies. And another thing that I hadn't mentioned about cookies is that they are established for a domain, which is important. They can have security risks as well, above all when they do not specify the subdomain, like in those cases. That doesn't mean there's a problem here, but it could be a problem. You'd have to study it to see what use it has, and then the size as well as the expiry, whether it's got HTTP attributes and whether they're secure, and whether they're going to be sent by SSL or not. And if we talk about the Flash cookies, these are a little bit dead, although they're still being used. In 2011, there was a lot of noise about this because they weren't controlled, but now they are controlled, and Flash has a system for storing information in the hard disk, just like any other browser plugin. And in 2011, the press talked a lot about this because traditional cookies were not being used. Flash ones were being used and to store files, and one of the advantages that offered was that they were cross-browser. So I stored something, for example, in Internet Explorer. I went to Firefox, and since they had the same plugin, they both accessed the same application. And where it was authenticated in one, it was authenticated in the other. So the server knew, regardless of the browser, that I was the same person. And I might have thought, since here I've not authenticated it, then they wouldn't know who I am. But since they're using the shared plugin, then I had the same problem with both. They're stored in different paths depending on the browser. We've got Internet Explorer and Firefox. They do share the same one, which is Chrome. And sorry, that's Flash. And when we go to rub out or delete the cookies, now we know that they can be stored in Flash, and they delete them from Flash as well, whereas we didn't know that in the past. Here I have an example of a website with cookies in Flash. So we're going to take a look at that. We've got a website, moviepain.de. Sorry, panel. Movie panel. I thought it didn't sound quite right. Okay, so this is a website. It's got popcorn and lots of other things, lots of things in German. If I open up the developers bar to look at this, I tell it to disable the cache and preserve the log, and we can see what requests are being made by the website. Good, okay, here we have it, and we can see it there. The request has been made to an SWF. It's storage.swf. It'll be in there somewhere. And as you know, the files in Flash are binary. So I copy, and we're going to decompile with show my code. We're going to use, here we're going to pass the URL, and we're going to tell it, well, okay. With this web page, we compile and we see the source code. In theory. Well, oh, it didn't work. Okay. Let's see. Control V. It can't go wrong this time. I don't know whether there's something in the capture that I'm not seeing. I'm going to try again. No, it doesn't want to compile it. Well, what we see is action script, which is a source code of Flash, which tells us where it's stored. And in this website, well, I know because here we can see script storage SWF. If we look at the source code, store.swf, here we have it. And we can see how the call is being done from here. And we can see it's giving a value to the key to store the file in the browser. This is a library which does not belong to the website itself. It's a Pensos project, so they haven't done that themselves. It's a Pensos code which has been done. It says SWF store is a JavaScript library for cross-domain, etc., etc., and talks about the compatibility and how it's used, which is the code that is in that website. And within this, we can see that there are lots of projects for this. And that's normal because people want to store cookies, they want to do things, and it's not always going to be, with bad intentions. So this is an example. Here we have the source code of the Flash. We have to compile it. We don't have it here, but it has to be somewhere. Well, that makes no difference. It's JavaScript, which is very simple for storing this. These kinds of things are very common because there are developers that use libraries such as the one we've seen, and they don't know really quite how they work. So in some cases, we're going to see that they are using tricks, which are a little bit strange, to store data in the browser without really complying with cookie regulations, but they're not aware of that. For example, there are lots of WordPress plugins that store cookies, or things in the browser's cache memory in a strange way. So you have a plugin and, well, I mean, you obviously don't really look at how it works. And there may be risks associated with that ignorance. Risks for the user. Silverlight, well, this is exactly the same as with Flash. Flash has got maybe a year left, and Silverlight even less. It's really dying, but it was similar to the Flash cookies. Here we have the Flash that would be necessary, but in the end it's an obsolete technology that nobody uses anymore. User data for Internet Explorer. Well, as I said before, this arose as a temporary solution to a problem that Internet Explorer didn't support HTML5 after the Explorer version 10. It does, and this system is very dangerous because the cookie doesn't expire. It gets stored forever, and so people with a website have no real control over what is being stored there. It's only supported by Internet Explorer. And here we can see a JavaScript code of how it would be used. And, well, it has its own functions and such like. It's irrelevant because it's also really dying out. But we have third-party libraries that detect the version of the browser, and if they see that you've got Internet Explorer 9 and they want to put something into local storage, HTML5, then they would use user data. If it's for authentication, then that involves the related risks. If we talk about libraries that have this, we've got persist.js, and it uses different mechanisms. It's also very common to have a spread of the cookie in many places, in Flash, in Silverlight, in the user data, etc., everywhere we can, so that if one of them is deleted, then I can recover it from one of the other places and extend it once again. This library uses Gears as well, Google Gears, which is like a bit like Flash, Silverlight, so on, but it's also completely obsolete. We're going to see Well, if I go to GitHub, this is the project. Here it talks about how the library works, but now, well, since we know what it's called, we are going to do a search. It's called persistmin.js. We're going to do a search in websites that use that library in order to see it. There's a website that allows me to search in HTML, and I don't know quite. I think this would be it. Let's see. Yes, persistmin.js. With this website, I'm going to see what websites have in their source code this library. So there are loads and loads of pages. Here we can see quite a few. So, for example, if I go to this one, access map, I don't know what's there, so don't be frightened. You know what internet's like? Let's see. axsmap.com. Okay, nothing strange here. I'm going to open the window of the developer. I load the website again. We don't want them to know. Okay, so if we take a look here, it is loading the library. The search engine has worked correctly, and we can see here we've got the information here. It's loaded. We've got 500 errors in JavaScript and the source code. I'm going to copy it. JS beautifier. Let's have a look at that code a bit more in detail. Since it's minimized, I take it here. Oh, is it that small, or have I copied it wrong? This is a very small version. Well, I think here we can see it. Okay, here we have it then. We have the code, the JavaScript code, and here we can see how it's searching to see if we have the Google gears activated. It's going to do the different checks in order to later on store the cookie in different places. Here we can see how it's looking in local storage, global storage, gears, cookie, Internet Explorer, Flash, and this is normal. There's nothing strange here. It's legal because they're storing cookies in controlled places. So if we look at what we talked about earlier about the SQL cookie, it works with that. Well, I'm sure you understand this if you work in programming, but it defines the cookies as if they were SQL. Here we have all of the necessary code in order to get it to work. And here I had my video example, so continuing on. Alternatives to these methods, which are normal and traditional, there exist other methods, and this is a fact. They're called zombie cookies, super cookies, so they have different names, and what it's all about is using a different mechanism, which are not the ones that we've looked at already, in order to do exactly the same job. To get to know who the user is, who's behind the browser, and go a step further. If the user deletes the cookies, we will still know who that user is, even though that user has deleted those files. Here we have another project similar to the one that we saw before. It's no more relevant. What it's like with the session cookie, it doesn't persist, so there's no greater relevance there. And one of the most important ones to talk about would be fingerprint, the browser fingerprint. This is used a lot. It's really widely extended. It falls outside the cookie law, and it's for all of the files stored. Here, the fingerprint doesn't store it in the browser. What happens is that the characteristics of the browser and the computer are taken, and a digital fingerprint is taken of that person. So what characteristics does it see? Well, a whole load of them. And we're going to see some of them, the installed sources, the installed complements, the IP. If it's a mobile, they can see how charged it is, the time area, whether it's tactile, the internal IP address of the computer, and there's something that's called WebGL, which has specific characteristics such as the graphic card that we have. Hundreds of things, and with all of that, it's able to know our string. They identify it. They identify the users as a string, and so the next day when I connect, once again, if I connect to that website, it compares, and if it sees it's the same fingerprint, then they know it's us without having had to store anything. Who uses this? Well, marketing companies, of course, but from a security perspective, it's used for security purposes as well. For example, if you're contacting from a new browser, maybe it's Facebook, the first time you contact, it says, this computer's new, hang on. And so every time a new computer connects, it can have this warning, and it checks whether you're connecting from a strange place, and it tells you to introduce your password or your authentication data. And for example, if you see specific characteristics and all of a sudden you see a new computer which is doing a transfer of a large amount of money, it says, hang on, we're going to go to a second authentication process because there could be a risk here.
So after all, we'll see this a lot. And security is always fighting with privacy, just like the security cameras. If you wanna survey or monitor someone with a security camera, you're losing some privacy. And there's research from 2012 talking about the leading companies in marketing, talking about their JavaScript mechanisms for fingerprints. Nowadays, 10% of the internet is using this without knowing it. Mainly the large companies associated with marketing projects. There are open source projects and commercial companies. Yesterday I saw one I didn't know about. It's like augur.io, augur.io. This one here. It's a commercial company that is not shy when it comes to saying something like cookie-less tracking. They allow you to track users without using cookies, which is like, what are you talking about? There is a legal loophole there, but this is theirs as a script. They have a JavaScript and they do fingerprint techniques. Fingerprint, GitHub, and this project has evolved. In fact, the presentation is here, it's being included here. It's evolved to a second version. It includes these 24 different data points, and it knows whether you are in incognito mode or whether the .NOT track is activated. And if we go here, the Fingerprint 2 project, I really liked it to do because it includes that, but the best thing is what it is going to include in the future, whether you have two monitors, things regarding the camera, where you have a DRM support, or the accelerometer of the mobile device. So there are many things that make us unique on the internet, and they don't even need to implement everything on the code for the library to work. This will come afterwards, but it's still good. So let's look at some fingerprint examples. I've actually brought a couple of them here from cool webs. One of them is space.com, a NASA website. It opens again the developer's side. I can preserve the log, I can delete everything. And let's wait for this to load. It's loading like too many things, but the library that includes this is called buttons. And this is still charging here. It's got some nasty bits. Let's hope it will finish soon. And it keeps loading. Let's hope it will load again. It looks like I have no more internet connection. Oh, I do now. So here's the library and the buttons.js. And funny enough, that JavaScript library and this top bar with icons is a supplier or a provider that allows you to do a more social website. So they give you JavaScript and they say, okay, embed it on your website and we'll add the buttons to you or for you. So these people probably put it there. Is this JavaScript here? I copy it, I make it beautiful, and here I'll quickly look at it. And I'll actually write it on some notes to do better searches. Now it's been converted. And here's the JavaScript. And it will allow me to make it bigger here. Okay. Doctor, my notes are not working. Okay, so the library is massive, and this is fingerprint side. Here, I've seen 300 million of similar JavaScripts, but these STF app is showing something different. So here it shows what it has: Flash, Acrobat PDF, QuickTime, Real Player, and many other plugins such as Skype and others. Below it looks for the real solution: the date, the time zone, the fonts the machine has installed, the browser version. And here it gets a function with all that information, with the host name and everything, and that data is sent as a unique hash, so it does that print. This one is not too heavy, it checks just a few things, but if I do the same exercise as before and I look for the fingerprint, for example JS, we'll see how from these about 2,000 results, and I don't really know how this browser works, but how this search engine works, but we'll see that GitHub library on different websites. So probably the library will have a .meme version that will appear here on other places, and so on. So I've lost the GitHub, but the only fingerprint 2 example was the same GitHub. I don't think it's worth keeping explaining this, but another alternative to the fingerprint is directly doing a dynamic JavaScript that is kept on my browser's cache. So I go to a website, the website checks whatever it wants and gives me a normal cookie, but then it generates a JavaScript that says, well, keep this JavaScript the variable with this session's value. So I'll only have this JavaScript, someone else will have a different one. And next time I go to that website, whenever I check that JavaScript, the web server will say, well, I've given you already this JavaScript and I'll not give it back. Since I already have the variable with a certain value, I'll recover it, and that's it. So you know the battle is lost. And this is used a lot. There's a lot of software like Google Analytics that does it massively, and it's very common. And there's no way of getting out of it in a simple way. The only way of doing it is deleting the cache, and we'll see many problems with it. Here I will show you a video, and I actually had a demo, but this is a very interesting video regarding the regional government of Catalonia website. It's been changed, but we're going to see a JavaScript here. And here we can see the resources. Here I'm keeping the navigator's cache, the cookies.
Me pide traducir del catalán, le digo que no.
So it asks me whether I want to translate from Catalan. I say no, and here there is a JavaScript with a variable, and this one here is assigning a specific node on a temporary variable. So when I load the Jankat's website, is loading external content. This is a very commercial and common commercial product. They probably have some cloud services and so on. And if I write down that link, the value up here is the same because it's in my cache, and it will be the same all the time because I'm not recovering it actually. So here is the HTTP request. Just loading the same thing once again. And if I leave the cookies in the cache, because to delete the cookies I load the website and I get a new identifier, and that doesn't make sense. So I'm sending the traditional cookie. It knows that it doesn't correspond to that identifier and generates a new one. So after deleting the cache and the cookies, it also generates another token. It is pretty random regarding the HTTP protocol because it's trying to deal with the cache and the cookies. When the cookies don't correspond to what I had been giving, it needs to generate a new one. So it tries to synchronize with what it has in its cache and its cookies with what I have in my cache and my cookies. Okay, another similar mechanism, also quite problematic, although not as much as it should, that has been widely used and keeps being widely used, is a HTTP heading called etag, used to manage the browser's cache. Eventually, when a web server gives me an object or an image, it says, well, this image has this tag, which is a code. Next time I connect to the website, I'll ask, hey, I have this image that has this tag you gave me the day before yesterday. And the server side will check that figure and say, okay, if it's the same one I have now, it hasn't changed, I'm not giving it to you. The page hasn't been modified, you use the one you have in cache. And I said, okay, but it's a new one, so I give you the object and I refresh it. So you would discard it. And my navigator will ask about file or about an image. The web server gives me the image, and here we see the e tag, that code, and it has a certain size. It's giving me the full size. Tomorrow I'll go and I'll ask once again for that image with the e tag I've been given. But when I ask, it's not e tag, it's a whole different name. And if the server sees that this has not been modified, instead of giving me a 200 as it did, and giving me a fourth of a mega, and say, okay, I'll give you 304. It's not been modified, so it's saving bandwidth, which is the main purpose. And this is used so that the server side gives me a different t tag per person. If you have a cookie, I give you this t tag. If you have a different cookie, I'll give you a different t tag. And everyone has a different t tag. Since after a few days or hours, you will request that e tag again. I'll say, okay, this is the cookie, this is the e tag, and I can play just like we did with JavaScript. There are quite a few projects. One of them is cookieless, but on GitHub we have about 8 different ones to do this. Well, this library for you to include it in your Ruby on Rails or Jungle application. And there are many libraries to do this little trick on the browser. There's some old news. There was a company called Kissmetrics dealing with data analysis. They got caught doing e-tags and say, hey, you're doing strange tracking to the users, and they were fined. Kissmetrics is a massive provider that many companies use, but this method is still widely used. Let's see an example of how this is used. I checked this one yesterday actually. It's not a very difficult one. It's lastfm.es. Yes, that's the one. I'll delete everything here. And here they use a provider. Let's see. Did it finish loading? Anon. I'll just try to find it here.
Falta esto de que no sea mi navegador, me falta por aquí el dominio, me falta por aquí el etag.
Missing the domain, the e-tag, the browser. I'll try to do something here.
Estos son... Hoy en día cargas una web, cargas contenido de todo.
Nowadays, when you load a website, you won't load content from everywhere but for the website.
A ver si es este.
Could it be this one?
El nombre es otro, lo que pasa es que se parece.
The name is different. cbsi.com.
Anon.
Non. A-N-O-N-C. I'm going to load the website. I'm going to give it another chance. 600 requests.
Tenía otra web china.
Another Chinese website that I could try this with. I'm gonna go to that one. Sinacom.cn. sina.com.cn. And here in JavaScript it's called Beacon Sina HJS.
Vale. Bueno, en esta otra web china, la de la SFM...
Chinese website, I don't know why last.fm was not working, but this Chinese website, there's a JavaScript that this website delivers, and I don't really know what it is, sina.com.cn, with the e-tag heading. This JavaScript has this identificator, and suddenly having the IP address as an e-tag is kind of weird. I don't know what's the purpose of that, but it's even funnier because if I go to JavaScript and check it directly, we see that it gives me back a JavaScript and a variable, and this is a mix of this single JavaScript technique and the e-tag. So what's the point of a variable with that cache value? None. So if I check it once again, I get different values. I have deactivated the cache. So these are the different requests, and I load it up again. This is the last request. If you notice, here I can disable the cache. So funny. So source, response request, view source. Looks like the computer is the other way around. Here you can see the cookie we're asking about, and one of the funny things is there's a Signal global cookie And this is what the JavaScript in the tag is giving me back. What doesn't make any sense in an HTTP world is that there's a cookie that has a JavaScript variable, and that's a code that the cache should give me. But this is establishing this cookie based on the top value. And if I come here to the cookies, I'll delete everything. And here we can see that I established many cookies. I can delete them. And these kind of things tend to behave in a random way. And to get it to work, I disable the cache. And then I actually need to delete both the cache and the cookies at the same time. Okay, but I've got nothing here. Okay, so here I've loaded it. I got a different figure. I take out the disable cache, I load it again. And if you notice down here, the heading that I'm requesting about is if none match. I'm returning the value it had given me earlier. So the web server, since I'm returning or I'm asking about this identifier, that is exactly like the E tag given to me earlier, it should render a 304 saying that it hadn't been modified. However, it's giving me a 200, as I can see up here. Why? Because behind there may be a code someone did and they don't care about returning a 200 or a 304. You just need the JavaScript you need or the E tag you need, and the optimization doesn't care. But for a proxy, a balancer, or any cache technology, or any real web server, it shouldn't return a 200 but a 304. Which is what we saw in the first part of the video. To see how the normal E tag works, because if we don't understand it. And if you notice here, I'm doing a test with an image. And when I ask with the if none match, it should render a 304. It may do something weird, but the E tag is not the only cache heading. And the HTTP cache world is a nightmare. Some people even send you customer headings to a server, and finding someone who knows about cache and cache optimization is very difficult. There's another heading called eModify signs, which is not a modifier but a date. It gives you that date, and then you can ask, hey, you gave me this file and have this date, has the date changed? And based on the date, he knows whether he needs to give you the object and say, no, here's the one in the cache because the last one that I stored. In this case, the customer uses the last modifier. And haven't seen this widely used. I've searched, and it looks like it's a bit more complex because you need to give a unique date, and if you go to seconds, you could give a different date to everyone, but you get the same thing with the E tag. And since there are many libraries already done, you just get a library and everything's set up. But potentially, this could happen. Another method that is a lot newer, is not being used massively, at least right now. It will probably come in the future, and it is using a heading which is a strict transport security. Funny enough, it's a heading device for security issues that forces the navigator to use a secure connection, so that you tell the navigator, well, if you connect through the HTTP, go to HTTPS. I'm not going to save any content through HTTP. I work for a bank, and I can say, well, you can connect to the bank through an open Wi-Fi. We send headings for your browser to connect through SSL. For you, it's transparent. I mean, the heading could be modified, and there could be unknown attacks. From a percentage perspective, we make sure that all our customers connect through SSL all the time, even though they're writing HTTP. And it's not like the bank is doing it, but Google, PayPal, everyone does it. It's really difficult to do a man in the middle and have a Wi-Fi network and get the credentials because they have these kind of headings. For cookies not to be transferred with secure activated through HTTP, and for people to always go through HTTP and never through HTTPS. So this heading is stored within the browser that we do pinning within the browser, and when this is stored inside, we can recover it afterwards. Since this is not being used massively, I looked at about 6,000 or 7,000 websites from Spain. I didn't find anything, but there is a project by someone who put this on the table, and this has been seen from 2012 when they started talking about the C tag, where they use this method. And he said, okay, your tracking ID was sent, and this is a number that is a unique number for me. If you reload it, you get the same number, no matter what you do. In fact, you can open your developer tools with a browser that you know best or better. That was Firefox. Okay, so he will get a new one of D1 deep 0. So say, okay, delete anything you've kept here. Delete. There's nothing here. We're gonna delete all this. There's nothing here, nothing here. And you say, okay, tell it to delete the cache. There's no cache, nothing. But it generates the same, and you're like, hey, how is it doing it? So I go to private mode now, which is like the porn mode to watch porn pages. Had you never heard that? No? Okay, I must have weird friends then. Porn mode. There's an anonymous gentleman here. This one is not reading the cache, it's not reading anything. And he renders the same number again, so I'm being tracked, even from outside the incognito mode to the inside. And this is pretty amazing, because not even the incognito mode, where the browser has no plugins, cache, for the browser gives me the same results. The incognito mode stops being incognito, and this is a vulnerability within the browser. The Chrome people and Chromium and the open source project is aware of this. They know they need to solve this, but this is about the protocol definition. It's not simple, it's not just about applying a patch and fixing it. So the implications are quite big. But people are usually okay with the e-tag or the e-ping, and they don't go to this. But we're still in a pretty new moment of this, but it's not widely extended. Remember that porn mode on the incognito mode is dangerous. I think both Chrome and Firefox have a commercial name for it. Another security heading to which the same thing happens is the content security policy. It's a heading that is being implemented now, it's not widely spread, and here's an example. What is this useful for? Well, to avoid security problems, the famous clipjacking and cross-site scripting. When you connect to a web and you say, okay, I'm space.com and I'm going to load content from all these domains, twitter.com, facebook.com, the content, the external content that were loaded get identified on this heading. So if it's going to load images from the outside, it should say so in the IMG SRC tag. If it's going to load scripts, it should say so here on this tag. So if anyone is going to exploit a cross-site, they want to load external JavaScript to have access to my cookies, for example, the browser shouldn't let it because it's not inside this specification. Besides, it gets so the value of the heading and the cache time of this tag and last, something very interesting. And all the violations of the browser to load external content get sent to the website to tell you. So if something is misconfigured, I can see that someone is trying to load content, and if a cross-site is done from somewhere, I can see where it is. And these are security measures that are very useful to detect vulnerabilities, correct them, or correct attempts or failures in the headings design, because this is not simple. So we can go to a Facebook with a massive heading with all the content and so on. And it does take a bit of work to manage this heading. This is why we have the report URI attribute. So this is a URL and a heading sent by the browser, and at any point in time I can tell each of my customers and give them a unique URL, so they can report to me with a unique URL, and I can say, okay, this URL is for this user, and then I can do a violation and load a pixel in something I didn't define in my old policy. I provoke a violation to provoke the browser reporting that something is wrong. You look poker-faced, but if you have any questions, please let me know. Okay, content security policy. There are many ways of defining it, and until we got to it, we can do it with X hyphen content security policy or other mechanisms. Content security policy ping. The good one is content security policy. That's what most people are using. And when you have the ping, that's for that information to be stored in the browser for a certain amount of time. Last heading, similar, the public gate pinning, or the public key pinning, another HTTP heading established for security purposes that does a pinning certificate based on mobile applications. And if someone does a man in the middle, since the certificate is not valid, it doesn't give you the option of continuing and risking it. It just doesn't connect. And this avoids the same thing. If I'm with a browser, the first time I connect to an SSL page, if I get given this information, I'll get a certificate identifier, a backup of that first certificate and how long it's going to last in the cache and whether it includes its domains. So if I get a certificate when I'm in a committed network or compromised network with security problems, and the ID, my ID given 2 months ago, doesn't match with the ID I get given now, I say, okay, you're not going to connect through SSL because this SSL certificate is bad, and I wouldn't have any problem with a man-in-the-middle attack taking place. So there's also a parameter, an attribute, which is report URI or URI, and this is a URL that could be a single identifier for each of them. So the problem we have here, from the perspective of doing tracking, is that if we set a ROM ping, it will not be able to connect. We cannot do a violation of the certificates. If we do so, the user will not connect. So we do it at the backup. Backup ID, that's where the certificates violation takes place. Okay. So one of the most relevant things here by Sami Kankar, who was here, and on a study he did, and with one of his tools called Lever Cookie, he actually implements many mechanisms to store cookies, and some of them are quite strong. One of them exploited the vulnerability of Java to register a file on the hard drive, and then the next day they exploited the same thing to exploit the vulnerability of the file. You're exploiting the vulnerability of a browser, and that's not very common, and I've never seen it before. It is true that EverCookie is on GitHub. Their source code allows you to use any method you want, and eventually it does a split or a spread of the cookie wherever it can, and if you delete the cookies, it will try to find it in different places. Well, I got it from eTag, I'll put it back in the cookies, and it does persistence that way, as if it was malware. And EverCookie is used a lot without the vulnerability exploitation side.
If I go to EverCookie GitHub, Here we can see the mechanisms that it uses. We can see that we've got the exploit. This exploit, this is quite an aggressive one. Here we've got JavaScript is called a cookie. If I go here then, and if I do it right, evercookie.js, and we'll see that quite a lot of websites appear. Even some, well, in some of them we're talking about big websites. I can't remember right now. I think this is the one I had in the video. I've got it here. Let's have a look. This is the demo. Keep to share. CC. We can see it uses the library, but we don't have to go that far. Anything here, for example, any of the ones here, a login page in a language I don't understand. If I look at the source code, here we can see it, how it's being included. And here we can see a little bit of the source code where we have the evercookie flash. They've not even bothered to change the code. They're using the flash method. And it adds more and more codes, more and more things, different cookies and so on. So, as a programmer, if I want to include something like this, I can... well, it has certain implications with regards to what's behind it. What I didn't say about evercookie is this is something that appeared in the press a few years ago, that the NSA, when the documents were leaked, when Snowden leaked them, there was an investigation of how to catch the Tor people outside of Tor. So one of the things that was valued was to use evercookie, and here, well, they took it into consideration as one of the possible alternatives, and we all know that they're able to do it, as we all know that. We know they're able to do it. So, initiatives to avoid all of this. Well, there are several. Do not track, which is an HTTP header, which, well, the protocol of that do not track header says that the user has to activate it. So it's not by default. You have to go to the configuration of your browser and say, every time you connect to a website, don't do tracking. Everybody does that when they set up the computer. After WinZip, we go to internet configuration and we click on that to do not track. I mean, I'm sure about that. So since they thought about that, and they said, well, in IE10 we're going to have it by default, because we'll click it by default because otherwise nobody knows about it. And the people that work in marketing said, no, how are you going to do that? Because we're not going to be able to do any of our job. Our business will vanish and there was a lot of controversy when IE10 implemented it. And Apache said, if we've got Internet Explorer and we have do not track, then I'm going to eliminate the header. So now there's, in Apache, it eliminates the header. So they rethought it. They said, is it better to send do not track? Well, we can't do it because, well, it seems that there are more people, not just us, in the technology sector, so they changed their mind. So it fails because nobody does that. Nobody activates it. In Chrome, there's a checkbox. Nobody uses it. And there's another option, the out cookies, which are cookies which allow you to say that you don't want cookies. So this is the opt-out cookies. It seems a bit strange to me, but they exist. And for this, you have to go to a website and say, of all of these people that work in marketing, I don't want their cookies. And that will save a cookie to make sure that the marketing people don't know that you don't want their cookies. Well, I mean, let's see what the marketing guys do later on with those cookies. I mean, we send them the cookie, but I don't know whether later on, I don't know. And nobody does it, even if it worked. Even if everybody did it, everybody was legal and audited, nobody does it. Another, a much older idea is another protocol, the Platform for Privacy Preferences, P3P, which is an HTTP header which is sent to the servers. And it gives information about what the cookie is going to be used for. I mean, you go to the web server, everybody goes to the web server, right? To see what the cookie is going to be used for, no? Well, obviously not. And this was an initiative. It was launched by IBM with Firefox, con Mozilla. And at a certain moment, they said we've spent lots of time, loads of hours devoted to this absolute rubbish project, so they abandoned it. Then if we talk about Firefox Polaris project, it deals with privacy, security, and in Polaris, nobody's even heard of it. We'll have to see what happens. It doesn't seem, doesn't seem to be doing too well if nobody's heard of it and it's already existed for 2 years. But maybe one day it'll be incorporated into the browsers. Maybe we might see that in the future. And another initiative to attack this problem is by regulating it. Here, the Data Protection Agency, following the instructions from Europe, we have a law on cookies stating that we have to have a banner announcing the fact that a cookie is being used. And, well, what's happened? Well, as we've seen before, these kinds of banners that are so useful, everybody reads and nobody accepts. And, well, it's an epic fail because that serves no purpose, and everybody still uses the cache in the browser and they don't include that in that policy, so it makes no sense. And here it says, marked in yellow, highlighted in yellow, it talks about storage devices. Fingerprint doesn't store it, so you don't have to declare that you're using Fingerprint on a browser. So now we've already got an escape route. Maybe they could improve this law to include things that would cover Fingerprint and such like, but it's much the same, because if you still got a banner and you still have to accept, well, and if you look at what the policies say, nobody reads them. I do. I read them just for my presentations, because otherwise I wouldn't read it. If you go to look at the cookies on the website, you go to look at the cookies and you look at the cookies that the website gives you, and they coincide in 10%. There's 90% cookies that they're delivering, and they don't talk about what they serve, what purpose they serve. So that's what happens with all of this. Recommendations. Well, just like there's no way of escaping, it's a bit of a disaster. Above all, on the cache side, the most aware people may rub out the cookies, but not the cache. And if you don't rub out or delete the cache, then you're not getting anywhere. You can browse in private mode right now, well, and that's possible to a certain degree, but it's a real pain because you have to authenticate yourself for each website. Nobody actually does it. You can have safe or slightly safer configurations of browsers. For example, there's a JavaScript for making things or doing things automatically. We can empty the cache. Nobody does it though. We can use extensions, and I think this is going to change because everybody is really annoyed by the extensions that take away publicity adverts. For example, Yahoo doesn't let you connect to their email page if you have one of these extensions that blocks ads. And I think, for example, it's like, okay, we'll take away all the adverts apart from the one that paid for 200,000, which is the good advert. There are lots of things like that. There's another one, the Privacy Badger. And what that does, it does EFF, and that is an organization that works to protect privacy, and we understand that they won't sell themselves, let's say. And so they do work to a certain degree. We can also check our configuration to see how it works, and here we've got some references on the screen, and that's it. So that's the first part. I don't know if you want to ask any questions about the first one, but I've still not finished. Don't worry, I've still got another quarter of an hour to go. So any questions? Tor. They're asking me about Tor. Well, yes, if we use a proxy network, or sorry, a proxy server and a Tor network, would you still have the cookies? Well, the bonus track is all about Tor, and the proxy is going to make no difference. It's in the middle, but it's there with 3G and it's transparent to you. If it's a normal proxy, it's going to make no difference. The only thing would be the IP. The difference, because they wouldn't know your IP, but they still fingerprint, they can still store cookies. And what's more, the problem with the proxy is that you believe, or you think, or you might think that that's not happening, and they send a cookie when you're with the proxy, and when you're not with the proxy, they recover it and they know what IP it was with the proxy and without the proxy, and that's what happens with the Tor side of things. When it comes down to it, Tor, well, it's the same. Tor in itself isn't, a magic wand. You have to have lots of additional characteristics, specific browsers and such like, because otherwise you're going to have the same problem. And that's what we're going to talk about in this second part. You've talked about extensions. I wanted to ask you, is there one, for example, that might say it's random, or, well, I mean, how do you see that? Well, one of the things that I wanted to do was an extension to change fingerprint, and the extensions, I've only found one, which is called Stop Fingerprint, which in theory changes things. I looked at the source code, and it doesn't do anything. I downloaded it yesterday, I looked at it, there are 3 lines of JavaScript, and that's it. And then there are others that change the user agent. So it might say this browser, if we're talking about Internet Explorer or Chrome, it might change certain characteristics. But if it doesn't do this in a dynamic way, then fingerprint is always going to do the same thing. It doesn't get rid of the problem with the cache memory. If you've got modify, I mean, if it uses cache, it's still going to have the problem. And the thing with fingerprint, the only one that works of all of the things that fingerprint does, resolution, it does 40 checks or so. There's one that prevents it getting the internal IP of your computer, because with WebRTC, which is a JavaScript thing for video streaming, and it's possible to get the internal IP. So that can be, or at least there is an extension, but whenever it has whenever it sees an RTC web, it gets rid of it, and there are webs that have RTC but they don't work. But the webs that have RTC and they don't need it, well, they eliminate it. So these are very specific things. I want to do something, I don't know, one day in a master's project or something, because a lot of things can be done, I think, and I don't know why not a lot has been done. Above all, when we talk about fingerprint. Any other questions? Okay. If we talk about Tor, then I'm going to talk about this and then I'll finish. I'm going to run through it very quickly. I think that you all are familiar with Tor. No? Yes? Well, half of you. Okay, Tor is a communication network which, on the basis of hops, very high level, at least 3 hops, from one computer to the destination, it goes through different servers, hiding the IP, the original IP address, so that the destination does not know who we are. So people who voluntarily configure their computer or their server to serve as an output node, and these output nodes are going to be the last points in this picture that we see here. This is the destination. This would be an exit node, and you have to do several hops. And in any case, Bob is never going to know who Alice is. And this is used a lot. Well, this is a deep web, as they call it, and everything. And it's not more relevant, really, it's not greatly relevant, but it's related to mafias, terrorism, hacking, for illegal things, because there are so many hops. It guarantees the anonymity of the IP address. There's a lot of concern amongst the security forces because they want to know who Alice is when Tor is being used, because if she wants to do something, unpleasant, something unwanted, you can configure a proxy, and for you it's transparent. And that's a problem. So they're very interested in trying to find the IP address of Alice in order to send Alice to prison or to do whatever they see fit. And another interesting aspect is that within Tor they have their own servers. So you can have in a Tor network, you have a TLD, which are the onion points, and you can set up one of these computers as a Tor server, and you don't know the IP address. it's got a domain, and you're never going to know where that IP address is. So therefore, what it does is deep web. So if I want to set up a drugstore, if I want to sell drugs, I don't want anybody to know where I am working from. And this isn't traceable. And that's what we were talking about, the .onion with their own domain, and there's a great deal of interest to know where they come from. Things that I've seen, well, there are .onion servers which have LSO. They're doing strange things with cookies. And what's the objective? Well, it's about getting a photo, well, within Tor and outside of Tor, with cookies, with fingerprint, or of any of the techniques that we've seen, and then compare them. If you're able to take the same fingerprint and compare it on the inside and the outside, you can see the IP inside and the IP outside of Tor. Here we have the code, and this came out also when the Snowden documents came out, talking about a project with several providers. Here we can see Hotmail. And if I want to connect anonymously to Hotmail via Tor, then nobody's going to know who I am. There's going to be an IP for an exit node. And if I go back to Hotmail tomorrow with my IP address, if I've got a cookie and they recover a cookie when I was inside and outside of Tor, they would be able to relate me. And what's more, they would know that the NSA, are in those servers, and they'd be able to do those kind of things. Another thing that appeared here was another similar way of doing things, and this is the DoubleClick, which was an advertising company bought by Google, and this is the name of the cookie, in particular the DoubleClick ID cookie, and seeing it inside and outside, just like the document said. How would this be with fingerprint? I mean, imagine that Alex, in the Tor computer, I am as a hacker, because I'm going to be up to mischief, so I've got different nodes. I connect to the destination. Here we have a company. The AD is an advertising marketing company, which is asking for information, characteristics of my computer. I give them that, and they develop my fingerprint. So I mentioned if my destination is Hotmail, and with Tor I have that fingerprint, and from the same PC a month later I will connect to Hotmail again. It will load a JavaScript from a provider. I give them my characteristics and I give them my fingerprint, and here they get once again the fingerprint. If the two fingerprints are the same, then the IP address for Alex is Alex. It's that simple. There's nothing more to it than that. If we talk about onion services with fingerprint, with Tor, the websites are not indexed. There is no google.onion, so either they have the address that you want to access or you cannot access. So there are some directories, there are databases, there are things like that, but it's not simple. Nonetheless, I managed to get a list. Pepe, who's over there, has done a lot in Tor networks, and I asked him for all of the domains, and I decided to crawl them and investigate and to see how many of them are doing strange things. And from that analysis of not many, 800, 900 .onion domains, well, I found several that were doing fingerprint. Why? Well, we don't know, but those two JavaScripts were the same as the ones that we've seen. They look at the sources, the plugin, and they prepare a fingerprint. Onion services, which instead of having the JavaScript, they use external content, so they have a marketing provider, just like an ordinary person. Well, there are some like that as well, and I found those 3 examples which were included there. These are big players in marketing who devote their time to this, and they use fingerprint. Here I have the demonstration, but here I would need my computer. Let's see if it will work, because I've got the Tor set up. I've got a proxy. So is there someone? Can we try and see if we can connect my laptop? And I'm seeing already that it's not going to work because I don't have Ethernet. It's going to be complicated, but it was basically to have a little bit of a look, because I had... Oh, just one moment. I had done the web page. Well, I had done this website or web page that just tells you the IP address that you're using to connect and the hash of the fingerprint, and it's saved in a file with the fingerprints. So the idea is I connect like this. I'm connecting via internet, and then I connect using Tor. We'll see that the IP changes, but the fingerprint is going to be the same. And if I look at what has been recorded, these are my tests that I did yesterday in Tor and outside Tor with the fingerprints. Here we have an IP, and here we have the other one. One is Tor and the other one isn't. And here the fingerprint we can see is the same. And then I tried with the Mac, and that's where you can see different things. Should we try? Let's see, and I'll do the connection with Tor.
Y lo vemos. Si no se ve la primera, lo dejamos y paso a preguntas y ya está. La primero. Sí. Déjame que lo cojo yo. La. ¿Se veía? Bueno, déjalo así. Vale, no pasa nada. Tardo un segundo, ¿eh? Vale, estoy poniendo ahí el proxy.
So we've got the proxy here. It's going to be a bit kind of on and off, they've told me, but here we go. Basically, here we have my IP for now, and if you remember, we've got F2 CAA, the fingerprint. Here I have a button to go via Tor, and if we see what my IP is, what is my IP? If you look at that, it's changed. Now it's 108.2.5, and I'm not browsing using the proxy because the node is configured that way. And if I come here, this is the old IP 62. If I refresh, maybe the Tor button isn't here. Ah, yes. Okay, I have to, since it uses parameters. Okay, and here we can see that the IP address has changed and the fingerprint is the same. So, right now, outside of Tor and inside Tor, if somebody has that IP, they see this fingerprint, they do a reverse search, and they will see my IP outside of Tor, and they could come and look for me at home. And they do say that that happens. I don't know if anybody has any comments to make regarding that. Any questions? So we're finished now with that demonstration of Tor, so that you can see Tor is secure, yes, but you need to have a specific browser. The Tor people give you your own browser, and you have to, well, it's more secure than not using Tor, but it's still not secure. So, any questions? I finished early, we've got loads of time. Ask me questions. Do you want me to show you anything again? Or to look for strange JavaScript out there or something? Yes, and Pepe says that the Tor browser has faults. I think that's based on experience. Yes, it's true. It's true. And in fact, I think that's in one of the presentations of Snowden, one of the faults. I think there have been 2 or 3. One came from a presentation. They'd identified the fault in the NSA, but that's not the same, I mean, as marketing, where they're 2 different extremes. We're not trying to escape from NSA, we're trying to escape from the marketing people. Or at least that's what I hope, for the people that are here, at least. Any other questions? Anything else? I finished very early. Come on, we've got 20 minutes left. You've got me here. You can ask me anything you like. Anything. Well, if not, well, thank you very much. Well, I'll see you around.